So this is a classified topic 4 questions related to topic 4. You don't find too many questions from this topic, the electrolysis. So the first one, this question is about the electrolysis of concentrated hydrochloric acid is electrolyzed. So we have a hydrochloric acid and we did electrolysis of the hydrochloric acid. What are the ions present? Can you identify the ions here? What are the ions present here in hydrochloric acid? So
Teacher, is it like NaCl?
no, it's a hydrochloric acid.
H plus and Cl minus.
Good. So it contains H plus, one
OH
ion,
minus.
and Cl minus. And because acids and alkalis, yes, Abdullah, do you have a question?
I'm saying they haven't mentioned that whether it is molten aqueous.
But they use the term concentrated. So when they use the term
Oh,
concentrated, because a concentrated or a dilute is always referred to aqueous substance. So means even though they did not mention it as aqueous, but you will take this as aqueous. So what are the other ions present? It contains H plus ion and OH minus
and
ion. Now for positive ion, we check the reactivity. But in this case, we have both, like the less reactive ion will move. In this case, we have hydrogen ion, both cases. So hydrogen will move towards cathode. So if hydrogen moves towards cathode, what will be the equation for hydrogen? When one hydrogen moves there, it will take one electron from hydrogen atom. But hydrogen is a non-metal. So when two hydrogen ions will move there, they will take two electrons and it will produce a hydrogen gas. So we'll observe bubbles. So the bubbles
sir,
will, yes.
will we write every non-metal squared
Yeah,
diatomic?
diatomic, yeah, right. For every non-metal in electrolysis. For negative ion, we check the amount. The ion which is more in the solution will move, except sulfate, nitrate, and carbonate never move. So sulfate, nitrate, and carbonate never move. So this is a chloride ion and hydroxide ion. It's a concentrated. So which ion is more? Is it hydroxide or a chloride?
Chloride.
Good. It's a concentrated, so chloride ion is more. So the equation for anode, when one chloride ion is there, it will lose one electron and it will form a chlorine atom. But when two chloride ions are, it's a non-metal. When two chloride ions are there, they will lose two electrons and it will form a chlorine. Usually they don't write like minus E, they move the electron to other side. So what will the equation for this? We can also rearrange the two chloride ion produce a chlorine molecule plus two electrons. So this is again, if a chlorine is there, what is the observation if there's a chlorine gas?
Yeah, greenish yellow gas or yellowish green gas.
Yellowish green gas, right? Yellowish green gas and bubbles are there of the chlorine. So first we have, you can use a screen annotation to complete this equation. Complete the ionic equation for this reaction. That's right. So we have the two chloride ions are there. This is the equation what we have to write. So two chloride ions, it will produce chlorine molecule and it will give off two electron. What is this change? Is it oxidation or a reduction? Oxidation or reduction? Remember from oil rig.
Oxidation, sir.
Oxidation is a loss, reduction is a gain. So what change is this? It says oxidation. And whenever you write oxidation or reduction, you always use the term electrons, like it's a loss of electron or a gain of electron. So you will say this change is oxidation. And why this change is oxidation? Because it is a loss of electrons.
Like the full answer we have to write, right?
Yeah, it's of explain your answer. That's why the second mark is for explanation. 1 mark is for saying it is oxidation. 1 mark is for the explanation that it is a loss of electron.
Sir,
Yes.
we can like do these questions in our book also, yeah, like on a notebook.
I will share this on the Google Classroom as well. So you can download and do this as a practice. For the classified questions for each topic, having the answer at the end. You can see the answers as well. So you can cross check whether you're doing right or wrong.
Okay.
So right now, it's no need to copy anything on the notebook. Notebook, you will copy only the lecture notes or the key points which I explain. And for these discussions, just participate, active participation, what is needed from your side. So what is the observation at cathode? What will observe at cathode?
Extension of size, or simply
What will observe at cathode? The hydrogen gas is there. So what is the observation with the hydrogen gas? Good.
Hydrogen is cathode.
Hydrogen is formed at cathode. So when hydrogen is formed at cathode, the hydrogen is a colorless gas, so we'll observe bubbles. So here in the question they ask, in part B, they ask describe what is seen at cathode. So what is seen at cathode, we'll say bubbles. You can say effervescence, fizzing. These are the terms you can use when bubbles or a gas is formed, a colorless gas is formed. So fizzing, bubbles, effervescence. The next part is not related to the topic electrolysis. It's a subtopic which is related to acid, alkali, and salt. But we will just discuss now, and in detail we'll have a discussion about the pH related to the pH question in acid and alkali topic. The part D, the pH of electrolyte measured throughout the experiment. Remember, the pH of the solution is inversely proportional to hydrogen ion concentration. If a solution contains more hydrogen ions, then the solution pH will decrease. If a solution contains less hydrogen ion, the solution will have a higher pH. So if you see, we were having the electrolyte, we were having a hydrogen ion, we were having a chloride ion, we have a hydrogen ion and the hydroxide ion. When we carry out the electrolysis, so the hydrogen ions were moving towards the cathode and the chloride ion was moving towards the anode. Now, what happened to the amount of hydrogen ion? What happened to the
decreased.
amount? The amount of hydrogen ion decreased. So if the amount of hydrogen ion is decreasing, what happened to the pH of this solution?
It will
Decreases.
If the amount of hydrogen ion is decreasing, so what happened to the pH of the solution? The pH of solution will increase.
Increase.
So the first part, yes?
nothing,
Any
sir.
co-
Nothing.
Okay. So the first part suggests the pH of electrolyte at the beginning of experiment. At the beginning of experiment or at the start of experiment, it is a hydrochloric acid. Hydrochloric acid is a strong acid. So what could be the pH of strong acid? You have studied this in like grade 8 as well, grade 7.
2.
You can say 1 or you can also say 2. Any number less than 3. Then state how the pH, if at all, how the pH changes, if at all, during the experiment and explain your answer. So what happened to the pH of the solution? The pH of the solution will increases. And why the pH of the solution increase? Because the amount of the hydrogen ion or hydrogen ions in the solution and electrolyte decreases. Is it clear? Part D1 and 2?
Yes, sir.
Yes.
Yes.
Okay. The next is electrolysis is repeated using a molten lead-2 bromide. So you have it's a molten substance. So what happened to electrolyte? The molten
Used up.
substance. In a molten
Used up.
substance, the electrolyte is always used up. So it's a positive, negative, and lead-2. So it contains lead-2 ion Pb. It contains lead Pb plus 2 or 2 plus. B should be small because the first letter of the symbol is capital. The second should be small. And the bromide is Br with a charge -1. Now, the lead is attracted towards cathode. If lead is attracted towards cathode, what you'll observe? A metal will form. So what you'll observe?
Shiny
Shiny-
solid forms.
Good. Shiny
So,
solid.
yeah.
So shiny solid, you will say the bromide ion is there. It is attracted towards anode. What is the observation for a bromine?
Reddish brown.
Brown gas.
Brown.
Good. Brown gas, brown vapors, red brown gas, reddish brown gas. That's
Can
fine.
we say red brown?
Yes, you can say red brown.
Okay.
Now state two properties of a graphite which makes it suitable for a use of electrode. Like why we prefer the use of the graphite.
Inert
Good. Inert or unreactive, you can say. And what is the second reason?
and doesn't conduct electricity.
Good. Does not or does conduct?
Doesn't.
No, it's a good electrolyte. Like it's a good conductor of electricity. Graphite is
Oh,
having the
sorry,
free
sorry.
electro. We want the electrode to be made up of a material which conduct electricity.
Yes.
So if
Can we also say
No, it does conduct electricity.
so, this inert or unreactive is the same thing. Yes, Umar, what's your question?
can we also say it's cheap?
Cheap. Okay, let's see the marking scheme. Only two possible answers are given. Actually, cheap in terms of chemistry, like something is cheap or expensive, is not like the reason why we use or we don't use.
Yeah.
So as you can see here, conducting conduct electricity and inert or unreactive. Is it clear, this question?
Yes, sir.
Yes, sir.
What is the difference between a physical and chemical properties? Physical properties are measurable properties, like example, melting point, boiling point, density. These are physical properties. Chemical properties mean like when a substance react with other substances, how it react. These are chemical properties, like react with water, react with oxygen, hydrogen. That is refers to chemical property. Another question related to electrolysis. We have a dilute sulfuric acid. Can you identify the ions in sulfuric acid? What are the ions present in sulfuric acid? Sulfuric acid is H2SO4. What are the ions present?
Right. Sulfate,
H plus.
Sulfate, good. H
hydrogen.
plus, H plus,
Yeah, H plus.
H
and
plus and
OH
Can
minus.
I call it
OH
Sir?
minus.
Yes?
Can I call it hydrogen, or am I supposed to specify, like, when I'm
No,
speaking?
you have
am I
to
supposed
say, you have to say either you can say hydrogen ion or you can say a proton. H plus ion is also called
Okay.
proton. Why? Because one hydrogen contains one proton and one electron. This is a hydrogen atom. But when this hydrogen atom loses electron, we are left only with one proton. So hydrogen, there's another name for hydrogen ion, which is also called proton. So you can say a proton as well, H plus ion or a proton or hydrogen plus ion. But you cannot say hydrogen only. You have to say it's an ion.
Okay. Thank you, sir.
Next is what is meant by the term electrolysis? A 2-mark definition. So the key
Breaking up of क्या नाम है? Molten क्या होता है?
decomposing.
Ionic. Yes. Okay, give me a second.
Yeah, sure. You can use any space, even the space which is given, that's also fine. Or you can use any space on the screen to answer. Decomposition of an ionic compound when molten or aqueous, good. By passing current through it.
Process of transferring current through molten or aqueous solution.
No, actually, I will show you the standard, like the marking scheme answer as well. The reason is that if you write definitions, don't try to write definition in your own words. Why you should not write definition in your own words? Because there are always the key terms which are used in the definition, which is very important. Like when you see, like the standard answer here for electrolysis, what is the standard answer? 1 mark is for mentioning breaking down or passage of electricity. like breaking down by passing the passage of electricity or by electricity. And the second mark for ionic compound in molten or aqueous. So it's a breakdown of ionic compound in molten or aqueous state by passing the current through it. Or decomposition of ionic compound when molten or aqueous when we pass the current through it. So that's a standard. You have to learn or memorize this definition.
Oh, so can you write down the definition?
Electrolysis means the process of breaking down ionic substances in molten or aqueous state by passing current through it. So when we,
Sir, isn't it ionic compound?
it's the same thing. I use ionic substances, ionic compound. It's fine. The process, but you have to use the term, the process of transferring current through molten or aqueous solution. You have to use the term ionic as well, Abdullah. So you have to use the term ionic. Explain why inert electrodes are used. What is the reason why we use inert electrode? Why not electrodes which are reactive?
Unreactive.
So that they do not react with the solution.
Good. So they don't react with the solution or electrolyte. No, the term is why inert electrodes are used, not about the conduction here. We have to refer why they're inert, why we use an inert electrode. So inert electrode, the main reason for
that
using
they
the
do not react with the product of electrolysis.
Yeah. So the main thing is your answer can be in detail, but the main point it should be they do not react, or they do not react with electrolyte, or they do not react during a reaction, during electrolysis or process of electrolysis. You can mention anything.
Sir, I was about to write active as well as they can conduct electricity. So still I will get the marks because
No, you will
I've
not.
written.
No. If let's what you were saying, like you was writing, they don't react and they are good conductor of electricity. That is what you was writing. So
Yeah.
you will, in that case, you will score the mark because you have the point which is needed for the answer. Like the point which is needed is anything related to does not react, unreactive, does not change, chemically change during a reaction. That will score the mark. If any additional thing is there, that will not either deduct because there is no negative marking. If you write a whole paragraph and if even in a paragraph your answer is there is a right answer related to the question, then you will score the mark for a 1 mark question.
Okay.
The next is name the product formed at each electrode. Okay, let's say we have, this was a sulfuric acid. So the sulfuric acid, it contained hydrogen ion, sulfate ion, hydrogen ion, and a hydroxide ion. So which positive ion will move? So hydrogen is common, so it will move towards the cathode. And sulfate, nitrate, and carbonate never move, so hydroxide ion will move there. So what is, when hydroxide ion will move there, what is the product at negative electrode? What we'll get?
Hydrogen gas?
Good.
Oxygen.
No, hydrogen gas. Because at the negative electrode, the hydrogen is attracted, so we'll get the hydrogen gas. What about the positive electrode? The positive electrode, the hydroxide, the question is name the product, not observation. If the question was state observation, then your answer will be considered as right. But now if you write bubbles, you will lose the mark. Because the question is name the products, not the observation. Hydroxide, this will be considered as wrong. You know why it is considered as wrong? Just remember when hydroxide ion will move there, what it gives? It gives oxygen, it gives water, and it gives 4 electrons. So what is the major product we have to write? We have to write oxygen here. Only oxygen is
Oxygen.
accepted. No need to write water. Why we don't
Just oxygen?
need to write? It's already aqueous. Like dilute sulfuric acid, so already water is there. So additional thing which is formed is oxygen. Is it clear, this one?
Clear, sir.
Yes.
Okay. Then what about the ionic equation for the negative electrode? Negative electrode means hydrogen equation for hydrogen.
Yes,
What is the
sir.
equation? What is the equation for hydrogen? When two hydrogen ions,
2H plus
Good.
electron plus 2 electrons equals H2.
good. Two protons take 2 electrons, like 2 hydrogen ion takes 2 proton and produce a hydrogen gas, and as a result we'll observe bubbles, fizzing. Yeah, 2H plus 2E. E should be small here.
Yes.
E should be small. Okay. This we did in the moles one. We did that. In part C, a sample of a concentrated hydrobromic acid, HBr, was electrolyzed using a platinum electrode. The concentration of hydrobromic acid was 8.89 mole per dm cube. Calculate the concentration in gram per dm cube. So if I want to convert mole per dm cube into gram per dm cube, what we do? Mole per dm cube to gram, what is the rule? The
You
converting
divide by
divide or
1000?
multiply?
Multiply by the molar mass.
Good. Multiply by the molar mass. So we'll multiply by the molar mass. What about the molar mass of we will check the periodic table for the molar masses. What about the molar mass of H? It is 1. You can see the periodic table. The molar mass of hydrogen is 1, and molar mass of a bromine, it is 80. So what is the molar mass of hydrogen bromide? HBr. So hydrogen is 1 and the bromine is 80. So 80 plus 1 makes 81. So the molar mass is 81. So mole per dm cube to gram per dm cube will multiply by the molar mass. So what we do, this 8.89 was there. We multiply by 81. So 8.89 multiplied by 81. What's the answer here? In exam, especially for 1 mark question, there's no mark for showing a working. Like if you even directly write the answer for this, you will score the mark. 8.89 times 81. What's the answer? 720.09. But always write your answer in 3 significant figures. So if you write 720, that's fine. No need to write 0.09. Just write 720. Three significant figure. You should always focus on 3 significant figures. The next is explain why concentrated HBr aqueous can conduct electricity. What is the reason? Why if we have a
Because it has free electrons.
Ions are free to move.
if you use the term electron for ionic compound, you will lose the mark. You have to use the term that it has ions which can move. So what are the distribution of the marks? 1 mark is for referring that ions are there, and 1 mark is for referring they can move. I will show the marking scheme answer as well for this one.
We electrolyze the
So
electrons, sir.
no,
Ions.
not electrons. You have to use it. Contain 1 mark mentioning because it's an ionic compound, so it contain ions. And 1 mark is that ions are able to move or ions can move. Because in
So can we
ionic,
also
yes,
free to move? Ions are free to move.
ions are free to move. Yes, you will score the both marks. So when you mention ions, actually, you're not supposed to copy the answer from the marking scheme, but your answer should make a sense or should be related to the marking scheme answer. It's not like the exact word to word answers are needed, but as you can see, yes, ions are free to move. You'll score the mark. 1 mark you'll score for ion and 1 mark you'll score free to move or can move. But if you use the term electrons, you will lose a mark because the ionic compounds does not contain electrons. That's why. If it was about the metal and you use the term electron, yes, you will score the mark. Suggests why magnesium is not suitable material from which to make the electrode. Why we cannot, the magnesium can react with electrolyte or magnesium is reactive, good. Predict the product formed at anode if a concentrated HBr is electrolyzed. Yes, if you can write it is reactive, that's fine. So if you have H plus ion, Br minus ion, H plus ion, and OH minus ion. So hydrogen will move towards cathode. Which ion will move towards anode if it is a concentrated?
Bromine.
So the bromide ion will move. So what will the product at anode? So we'll have bromine. If you say
So
bromide, yes, you will lose.
Isn't it aqueous?
Yeah, it
Oh,
is
I'm
aqueous.
sorry.
It is aqueous because they mentioned concentrated HBr and AQ is written subscript. So it is aqueous as well. So aqueous means it contains H plus ion and OH minus ion. And it is a concentrated, the term concentrated for negative ion, the one which is more in the electrolyte, that will move. The bromide ion is more in the electrolyte, that's why the bromide ion is moving towards the electrode. Is it clear discussion? Anyone having a doubt? Okay.
Oh, sir, I have a question about
Yes.
magnesium.
Sure.
Why magnesium is not a suitable material? How would we know that magnesium can conduct electricity or not? Like we know that it is only
All metals are good conductor of electricity. So magnesium, when you check the periodic table, I told you how to work out the different, we have a borderline between the metal and the non-metals.
group 2.
Yeah, here. This is a border between the metals and the non-metal in the periodic table.
Yes.
On the right-hand side, we have the non-metals. And on the left-hand side, we have the metals. So magnesium is here, so it's a metal and all metals are conductor. That's why. So how you identify it is like conductor because it's a metal and conductivity is a characteristic property of the metals. All metals conduct electricity. Is it clear? Then write an
Yes,
ionic
sir.
half equation. Write an ionic half equation for, we were having for a cathode we want to write. We have hydrogen ion, we have a bromide ion, we have a hydrogen ion and the hydroxide ion. The bromide was moving there, hydrogen will move. So when two hydrogen ions will move there, they will take two electrons and it will form a hydrogen gas. So we'll observe bubbles. What do you mean ionic half? Ionic half equation means when we say equation at anode, equation at cathode, these equations are called ionic half equation. Like when because there's a separate equation for anode and separate equation for cathode. So we call them as ionic half equations. Full equation you will learn in preparation of the salt. When we prepare a soluble, insoluble salt by precipitation reaction, we have a full ionic equation. Okay. This question is related to the electrolysis of the copper sulfate solution. First, electroplating a steel object with a silver involve 3 steps. A coating of a copper is applied, then a coating of a nickel is applied, and then a coating of a silver is applied. We have a copper sulfate solution. So what could be the ions present here? What could be the ions present? Copper sulfate solution. So it contains copper 2 ion, copper valency is 2 plus. So it should be copper 2. And it is a sulfate, and this 2 is written here. So this gives you an indication it's copper 2. So it contains copper 2 ion, it contains sulfate ion and it's aqueous. So aqueous means it contains hydrogen ion and hydroxide ion. Now what happened here? This is the same concept. Just I will erase your annotation for a moment and to give an idea about the electrolysis. Just a minute. So we are doing the electrolysis by using a copper sulfate solution and using the copper electrode. So in the electrolyte or the solution, what are the ions we have? We have the copper ion, we have the sulfate ion, we have the hydrogen ion and the hydroxide ion. What will be the appearance of this solution? Can anyone say the appearance? How it will appear?
Blue.
Good. So this solution will appear blue. Now what happened? We have the hydrogen and the copper ion, but copper is less reactive. So it will move towards cathode. When copper ion are there, they will be attracted towards the cathode. It will form a copper atom. When it will form a copper atom, the copper atom, like it will stick to the object. So what happened to the size of the cathode? Increase or decrease?
Increases.
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 Good. So size of the
Increase.
cathode will increase because the copper ion gains electron, turn into copper atom. Then the anode is also made up of copper. So to overcome this, the copper atom will go inside the solution as a copper ion. So what is the equation here for the anode? The copper atom turned into copper ion by loss of 2 electron. What happened to the size of anode?
Decreases.
Decreases.
It decreases. Why it is decreasing? Because the copper atom is turning into copper ion. As a result, amount is decreasing and eventually this anode will be used up and we have to replace by another copper electrode. So that's how electroplating is done. Like copper ion move towards the cathode and a copper atom jumps into the solution as a copper ion. What happened to the color of the solution? Will it change?
Yes.
It
No,
will
no.
become lighter.
Will
Blue,
become
blue.
pale blue.
It will become light.
It will remain blue.
It will remain blue. It won't become paler. Why? Why it won't change a color here? Because the concentration of the amount of the copper won't change. As one copper ion is going out, another copper enter. So the amount of the copper ion in the electrolyte does not change. That is why the solution will not become paler. It will only become paler if the amount of the copper ion in the electrolyte decreases. Is it clear, this question, the idea about the question?
Yes, sir.
Okay. Now we move on to the main questions. This is just a concept behind the question. So you can use the screen annotation now. It's explain whether this process is oxidation or reduction. What is this change? Is it oxidation? Oxidation?
Reduction. Because
This is
it's gaining
reduction.
electrons.
This is a reduction because it's a gain of electron. Because a copper ion gain electron. How to identify in chemistry it is oxidation or reduction? We know it's oil rig. So oxidation is loss and reduction is gain. So if you see electrons on the left hand side, oxidation is a loss and reduction is a gain. So if you see electron on the right hand side, it means this is oxidation. If you see electrons on the left hand side of the equation, it means it is reduction or a gain. So what actually happened? The copper ions take 2 electron and turn into copper atom. It is not a loss. If it was a loss, then how it will be written? It will be written like this. That the copper atom turn into copper ion and give out 2 electron. That will be oxidation. This is reduction. So how to identify it's a reduction? When you see electrons on the left hand side of the equation, you can say it is a reduction. When you see electrons on the right hand side of the equation, you can see it is oxidation or loss of electron. So this is a reduction because it's a gain of electron. Is it clear, this part?
Yes, sir. Yes, sir.
Okay. The next is explain why the concentration of the copper ion in the electrolyte remain constant throughout. So you have to write this. The copper atom move out from the electrolyte and the copper atom from anode enter the electrolyte remains same. Like when this is a copper atom at anode and the copper ion is there. When one copper ion will go out from the electrolyte, at the same time, one copper atom from anode enter the electrolyte. That's why the amount of the copper ion or the concentration of the copper ion remain unchanged. And what is the marking scheme structure for this question? So you can use the formation of the copper ion or the copper ion at anode happen at the same rate or the same speed as removal of a copper ion at cathode. Like what does it mean? When one goes towards the cathode, at the same time, one copper atom enter from the anode. So the formation of a copper ion or for copper ion at anode happen at the same speed as compared to copper ion discharge or removed at cathode. Is it clear?
Yes, sir.
Okay. So this is about the electrolysis as a copper atom compiled in anode enter the solution, eventually become copper ion and copper.
Sir, I haven't completed it. And the copper ion in the electrolyte goes to the cathode and becomes neutral.
So you can say the rate at which the copper ion enter the electrolyte and the rate at which the copper ion leave the electrolyte is same, or the copper ion from anode same as entering the electrolyte is same as copper ion leaving the electrolyte. Is it clear?
Yes, sir.